The Arc de Triomphe, the Arch of Triumph, a symbol of Napoleon's victories over France's enemies. But today the French are celebrating a different kind of victory, a victory over technology. For France has now become a world leader in technology, having developed the world's fastest train, the TGV, the world's fastest passenger plane, the Concorde, the world's smartest credit card, the Smart Card, and the world's most advanced ISDN system, Numéris, all thanks to a sophisticated French computer industry. Today we take a look at French computer technology on the special edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by the Software Publishers Association, which reminds you that software piracy is a federal offense. When a few people steal software, everyone loses. Additional funding is provided by CompuServe, by PC Connection and Mac Connection, by Byte Magazine and Bix, the Byte Information Exchange, and by Intel Corporation, Personal Computer Enhancement.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. Gary, let me explain what all these toys you're doing here on the table. It's not Christmas morning. I'm trying to make a point. This is the Concorde, the Air France SST. Fastest passenger plane in the world, depends a lot on computers inside there. This is the TGV train, French acronym for very fast train. Fastest train in the world, depends a lot on computers to run that. This little thing here is a smart card, French invention, a computer chip built into a credit card. This little photo from a Newsweek magazine from last year is a picture of world leaders from Paris. The very first real news photo actually shipped from Paris to New York via ISDN so it could make the Newsweek deadline. These are all examples of French computer technology, areas in which the French are leading the world, in fact. Now, we might expect the Japanese to be ahead of us in some of these areas, but not the French. Is there some danger that we in this country are losing our role as world leaders in technology?
Stuart, I'm not too worried about that. There are some elements that have changed, though. For example, the space program was a very important part of our whole chip technology and Silicon Valley development. And that program, of course, has wound down since the Apollo program somewhat. The consolidation of a lot of the computer development and so forth into IBM and Apple and the major manufacturers is also a little bit bothersome, because that used to be the case. We'd have a few thousand independent developers doing their own thing, and that's where a lot of ingenuity came from. The standardization helps us, but at the same time it hurts us to some extent. Take an example that you used here, ISDN, Integrated Service Digital Network, which is a global, worldwide communications system for telephony-based rather than computer-based work. It's a very important thing that all that comes together over time, and it will, I'm sure, in the United States. But there's some resistance here because we're heavily invested in our current technology, and so they didn't have that same problem in Europe because they're wiring they were using copper wires essentially.
And in fact, in France, that country will be totally ISDN wired by the end of 1990. So we're going to begin our look at French computer technology with the ISDN story.
I can leave a message here. So
this is an ISDN telephone. It has an ordinary handset, a numeric keypad, and you can plug it into a wall socket like any other phone. But that's where the similarity ends. Telephones that operate on an integrated services digital network, or ISDN, behave more like computer terminals than telephones. They can receive calls while the phone is in use, store numbers and messages in the order received, and automatically identify the incoming numbers.
The memory here, you know that
what makes that possible is ISDN's separation of signaling and data lines to maintain a permanent link between the user and the network.
And then it calls back the number.
By the end of 1990, France Telecom, the French telecommunications agency, is counting on ISDN to transform its telephone lines into an all-purpose network for transmitting voice, images, and data simultaneously. The potential applications extend far beyond usual telephone communications.
Until now, we have about 38 projects. And what we can draw, I think we can draw some conclusions from now, is the variety of applications, the variety of companies in size and in market sectors. So if we look at the list of applications, we can see that it goes from images to documents to multimedia databases to video catalogs to transmission of high-quality sounds, etc., etc.
The completion of a nationwide digital network follows closely behind France Telecom's first large-scale project, the creation of a national video text system. The video text network is accessed through a compact terminal called the Minitel, provided free of charge to telephone users as a substitute for phone books. Compared to a typical telephone line, the ISDN's throughput is staggering, 64 kilobits per second, at least 10 times faster than a conventional phone network. It takes about 3 seconds to transmit a high-resolution image, or about 1 minute to send 500 kilobytes of data.
Continuez tout droit.
ISDN's speed and transmission quality have given birth to some eye-catching presentations. At the recent PC Forum computer show in Paris, France Telecom demonstrated a colorful application for tourism. The color graphics are combined with verbal descriptions of popular destinations, tourist facilities, and local attractions. Real estate agents are also interested in the possibilities of ISDN to transmit detailed images of properties to distant clients. Along with attractive sales presentations, the ISDN quality pictures let homebuyers sort through potential properties without having to visit each one. While ISDN terminals are well suited for multimedia presentations, France Telecom is hoping that the network's speed and high resolution will attract a wide variety of other customers.
To sell ISDN, we found it very difficult. We knew that there would not be any killer application. One single application would bring everybody. So what we decided is to sell it by the example. So try to discuss with active customers, dynamic customers, find together applications, set them up, and then show to the other people, okay, look what we have done, and maybe you can have the same use of it.
SARD is a young Paris-based company producing hardware and software to store and manipulate ISDN documents. The SARD project was originally part of a government research program begun in 1982. Today, the spin-off private company develops and sells multi-user archival systems with optical discs for storage and ISDN lines for transmission. The software uses the Microsoft Windows interface, and it will run on a standard AT compatible. The only additional hardware needed is an ISDN interface card.
What we offer now is a simple software able to work on very standard PCAT. You can add extra things on the PCAT. The only necessary thing is the ISDN board and our software. You can have after that add high-resolution screen or laser printer and so on, but it's even not mandatory. So you can start with very cheap workstation for ISDN.
One of the company's major customers, the United Nations, is running the system on a wide area network to connect its New York offices with London and Geneva. The PC-based workstations can import images from different sources into standard Windows applications. Glaxo Laboratories is one of Europe's largest pharmaceutical companies and the first in Europe to build a document retrieval system using optical storage and ISDN. Medical professionals with ISDN terminals have access to over 3,500 documents describing pharmaceutical products. Glaxo gets around 250 documentation requests per month, 80% of which are for optically stored documents. Paper documents are scanned and the files compressed to 1/25th their original size. Doctors requesting paper copies have seen a dramatic increase in speed. The average time it takes to deliver a copy has dropped from 1 month to 48 hours. ISDN has also become popular with the print media, which has found a way to eliminate the time-consuming practice of physically delivering sheets of paper and photographs. At Keepa Press, a photographic agency in Paris, ISDN transmission is quickly eliminating the need to deliver physical copies to each one of Keepa's subscribers. The agency offers about 200 photos per day to newspaper and magazine publishers. Keepa has transferred about 40,000 photos to electronic storage so far. making only a small dent in the 3 million pictures still kept in file folders.
What's the most interesting for an agency, of course, is to show the pictures as quick as possible, and as many as possible, so that they have a big choice, and to order us the pictures immediately. And it's already possible to take the picture out immediately on a video printer, on a laser printer, and this gives a good quality already.
Paper photographs are digitized through a PC and then stored magnetically. Photos will eventually be available on optical discs, which can store about 52,000 photos per disc. At the receiving end, customers choose among a group of photos displayed on a terminal screen. Then, with a mouse, they can select the pictures they want and print them on the spot or wait for prints to be sent. Now that clients are accustomed to the system, they impatiently anticipate the day when all 3 million photos are online.
They are waiting for it, that it's ready, because it's not, well, really ready. And everybody is waiting for it, and everybody says that this is really the future of working with pictures.
In the United States, if you want to make a credit card call or use an automatic teller machine, you use a credit card, something like this, with a magnetic stripe on the back, basically a dumb storage device with a tiny amount of memory. But here in France, I can use a smart card. It's a credit card with a small computer built right into it over here. The smart card can actually process information, store all kinds of data, and provide a high level of security.
It says just what it has.
The French inventor of the smart card is Roland Moreno. His company, Innovatron, develops applications and licenses the technology. Moreno believes the chip-controlled smart card has overwhelming advantages in comparison to the more familiar magnetic stripe cards.
The weak point of the magnetic card leads the use of the magnetic card to what is called the online data processing. It's so weak that nothing can be made on the magnetic card itself, but must be delegated to a central computer by the help of telephone links. And the central computer makes the decision. So the magnetic card is dependent of central data processing, and central data processing has a lot of inconvenience, mainly on the question of the privacy.
The smart card's first big success in France was with the telephone company, which issues the chip-controlled cards for use with public telephones. Both France and Germany have flooded the telephone market with cards, almost eliminating coin payphones altogether. More recently, Minitel users have had the option of adding a smart card reader to their terminals, making it possible to pay for purchases made through electronic shopping. But the card's inventor foresees other applications as well.
One which consists to identify users of data processing or electronic system. For instance, cable TV or central database, important, powerful database, which needs a kind of subscription and the rest, or can be accessible only to a kind of users such as doctors, physicians, and the rest.
Innovatron is also applying smart card technology to do away with coin-operated parking meters. The company's personal smart card parking meter is a portable unit with a slot for a smart card. Drivers buy cards with a fixed number of units, good for a certain amount of parking time. The personal meter placed on the dashboard debits the card units according to the amount of time the vehicle is parked. An LCD screen displays the number of units left and the cost per unit based on the kind of parking zone and the time of day.
To manufacture it,
Bull Computer, France's second largest computer company, is also developing smart cards. The applications range from bank transactions to credit cards to student ID cards. Bull has several projects underway in the United States, but they see a very different market across the Atlantic.
In States, the problem is different. We are experimenting our cards with bankers, but we think that the biggest application will be in other areas, medical, physical access, logical access, more than in banking area to begin. Because to implement a new banking card, it needs a very long time. To implement an application in an hospital, it can be done in 1 year, for instance.
This is a card.
And Novotron's founder is not sitting still. In collaboration with Toshiba of Japan, he is developing a more functional computer on a card, complete with screen and keyboard.
Take the train here at the Gare de Lyon in Paris, and you could be traveling to your destination at over 180 miles an hour on the TGV, the world's fastest train. The problem is that at that speed, the engineer has to know instantly if any element of the system isn't working right, because at 180 miles an hour, even a minor technical problem could be catastrophic. The solution to that problem was for French engineers to design not only the world's fastest train, but the world's most computerized train.
The first TGV, or very high-speed train, began commercial operation in 1981 between Paris and France's second largest city, Lyon. Today, the 270-mile trip takes about 2 hours from the center of Paris to downtown Lyon. The first TGV route was an immediate popular and financial success, and it earned $250 million in profit in 1988. The electric high-speed system now carries 18 million passengers per year, and its success spawned the second-generation TGV, dubbed Atlantique, serving Paris and the French Atlantic coast. The Atlantique currently holds 2 world's records, with a cruising speed of 300 kilometers per hour, or 186 miles per hour. It is the fastest train in commercial use. But it also holds the world's top speed record, hitting 482 kilometers per hour, or almost 300 miles per hour, in December of 1989. The newest generation of the TGV benefits from a high degree of computerization for both operation and troubleshooting.
Every TGV train has 18 computers, 1 in each car and 4 in each engine. All the computers are connected through a high-speed network. By the end of this year, the network will be connected to ground stations by a data transmission radio line.
In the 1970s, engineers thought the only way to achieve speeds over 120 miles per hour was to use a totally new technology, like magnetic levitation. As late as 1989, some engineers claimed it was impossible to surpass 280 miles an hour on rails, but the new TGV proved them wrong. The engineering challenges encountered in running 300-mile-per-hour trains are many. Keeping the electric pantograph in contact with the overhead wire is one, and the need for advanced aerodynamics for stability is another. Computers helped to design the train's wind-cheating profile, and they have added totally new functions as well.
When trains are at the storage yard, the crew can prepare the equipment for its run by remote control. From a distance, they can operate the air conditioning, the food service car, the lights, doors, and the electronic destination signs. Once the engineer has taken control of the train, he can run all tests and verifications from inside the cab. Each cab has a computer with a keyboard, which allows the engineer to verify the signaling system, the brakes, and other important equipment. Once the train is en route, the computer system can inform the crew instantly of any malfunctioning systems. The engineer will see the information displayed on his computer screen and the recommended response to the problem. Finally, the computer memorizes the equipment problem and the conditions in which it occurred. It will send that information ahead by radio transmission to the nearest maintenance center so that repairs can be made as soon as the train arrives.
TGV passengers can get their tickets at high speed too by using automated touchscreen ticket vendors installed at major rail stations. The machines are connected to the central reservations computer, so along with buying your ticket, you can book a particular seat in a particular coach on any one of several hundred daily trains. The TGV may bring to mind a speed record breaker of another variety, one that also breaks sound barriers. The Anglo-French Concorde was the first and remains the only supersonic passenger transport in the world. Although its computers are of a different era, they are essential in providing the fuel-thirsty plane with its most efficient flight path. The aircraft's altitude and the engine's air intake are constantly adjusted by computer to find the path of least resistance within the plane's extraordinarily high cruising range. In addition to using computers to help operate their equipment, Air France and the French National Railways were two of the earliest information providers on the Minitel video text network. The online reservation system permits customers to check schedules and fares and book seats. The system differs from similar private services in the United States by its size and its widespread public availability and acceptance. There are now 5 million Minitels installed, distributed among private homes, businesses, and even in hotel rooms. The user base is around 15 million persons.
Now people have an easier way to obtain travel information. Before, they had to go to a station or a travel agent, or maybe use the telephone. But now they have a new channel, so I think our customers are much better informed about our services.
Traditionally, the French have been known for their wine, for their art, and for their fashion. But they've done more than develop world-class products in these areas. They've also shown great skill in the marketing of them. And that, perhaps more than anything else, is the real story of French computer technology. For whether it's video text or ISDN, smart cards, or the TGV, what the French have shown us is not so much how to excel in technology, but how to excel in the commitment to new technology and the marketing of it. After all, 15 million Frenchmen, all Minitel users, can't be wrong. For the Computer Chronicles, I'm Stuart Chaffee in Paris.
In the random access file this week, Apple has announced it will introduce a new line of lower-priced Macintosh computers. According to reports, they will include a color model to be priced at about $2,800 and a black and white version with a price tag of about $1,300. The new Macs will not be available until early 1991. Compaq says it is extending the warranty on its notebook-sized laptop computers following complaints of hairline cracks in the cases. The company is investigating the cause of the cracks in the LTE and LTE 286 models, but a company spokesman said the fractures will not affect the operation of the computers. The laptops were introduced in October last year and are the biggest-selling laptop computers in the notebook-size category. IBM is bundling the new Microsoft Works with its PS1 personal computers, which are aimed at the home market. Some of the features of the Works 2.0 include more powerful database functions, improved analysis tools in the spreadsheet module, and upgraded word processing and report capability. The IBM PS1 was first introduced this summer in several test markets. Sears has announced it will carry the PS1 in over 800 of its outlets nationwide. In this week's Ask Dr. John feature, a viewer wants to know the difference between extended memory and expanded memory. With the answer, here is Dr. John Heilborn.
The difference between an extended memory board and an expanded memory board is simply the way the memory is organized. With an extended memory board, all of the memory is available to the computer at one time. It's the kind that's used with most of the newer computers. Expanded memory, on the other hand, is used in small chunks. It's paged in and out of memory. The difference, however, as far as software is concerned, is this. All of the software, or virtually all of it, is at this point set up to work with expanded memory. So if you've got software that needs more than the 640K that came with your system, you'd be better off to get expanded memory or extended memory that has software that allows it to look like expanded to the computer. For the Computer Chronicles, I'm Dr. John.
Taking a look at this week's top 10 software titles for PC compatibles according to PC Connection, PC Tools Deluxe takes over the #1 position, followed by Windows 3.0. In third place is Expanded Memory Manager, with WordPerfect 5.1 coming in fourth. In fifth place is the Norton Utilities. Rounding out the top 10 are Quicken 3.0, Grammatic 4, InfoSelect, CorelDRAW, and Excel 2.1. Microsoft says it's forming a consulting group to help large corporate customers use its products. The group will offer executive education, planning, design, custom development, and systems and application support. Microsoft says it will also train its clients in implementing information management systems. A long-distance telephone company in Japan will begin marketing an image system that transmits and receives still images, as well as sound and text, through a personal computer. The system from KDD consists of a processor that displays transmitted images and text on the screen, and a telecommunications unit which connects a terminal to an Integrated Services Data Network, or ISDN. The person speaking on the phone can also highlight images and text on the screen and make them visible on the receiver screen while still speaking. Well, finally, opinions are divided as to whether engineer Gilbert Hyatt will collect any royalties now that he's been awarded the patent on the microprocessor. Hyatt was granted the patent following a 20-year battle with the Patent Office. Intel and Texas Instruments have been largely credited with the invention of the microprocessor, but Hyatt filed his patent application for the computer on a chip years before the two companies did. Analysts say that the 52-year-old engineer could collect millions of dollars in royalty fees. That's it for this week's Computer Chronicles. I'm Maria Gabriel.
The Computer Chronicles is made possible in part by CompuServe, which offers online information related to today's subject. Members type Go Chronicles. Non-members call for more information. Additional funding is provided by the Software Publishers Association, by PC Connection and Mac Connection, by Byte Magazine and VIX, the Byte Information Exchange, and by Intel Corporation, Personal Computer Enhancement. For a transcript of this week's Computer Chronicles, send $4 to PTV Publications, Post Office Box 701, Kent, Ohio, 44240. Please indicate program date.